Yes, now we shall start some numericals based on the prior concepts. The first numerical is a refrigerator has consumed 500 units of energy during a month. How much energy is this in joules? So what is it given to us? We are given that a refrigerator has consumed 500 units, means units are given, and during a month the refrigerator has consumed 500 units of energy, and we need to calculate, we need to find out how much energy, it's the same energy in joules. Now, as we know, 1 unit is equivalent to 1 kilowatt hour and 500 units will be equivalent to 500 kilowatt hour. If 1 is 1 kilowatt hour, and obviously 500 units will also be equivalent to 500 kilowatt hour. And we very well know, as we have learnt about the 1 kilowatt hour, its value is 3.6 into 10 raised to power 6 joules. Fine with it? And what we need to calculate? We need to calculate the same in only in joules, and obviously we will calculate 500 kilowatt in joules now. And obviously that it will be 500 kilowatt hour, that will be equivalent to 500 into 3.6 into 10 raised to power 6 joules. And the answer that we will get over here, that will be 1980 into 10 raised to power 6 joules, and we can combine them and we can get 198 into 10 raised to power 7 joules as an answer over here. And yes, we have converted now 500 units into joules. So this is our answer over here. Thank you. Yes, our second numerical is an object of mass 60 kg is raised to a height of 5 meters above the ground. What is its potential energy, and if the object is allowed to fall, find its kinetic energy when it is halfway down. So what is it? Mass is provided to us of the object, and even height is also provided above the ground. And we need to calculate the potential energy, and also we need to find out the kinetic energy when it is halfway down. When it is in the center of the way. So let us find it out. Now, as provided in the numerical, mass of the object given is that is 60 kg. Height is given, that is 5 meters where the object is displaced. And we need to calculate the potential energy and as well as kinetic energy when it is halfway down. First of all, we will calculate the potential energy. Potential energy is everybody know that is equivalent to mgh, that is mass, and to acceleration due to gravity and into height. And let us find it out. So what is it? Potential energy, this is equivalent to 60 into acceleration due to gravity, we can consider as 10, and obviously you can calculate it as 30 and in joules. So potential energy will be equivalent to this. Now let us find out the kinetic energy. Mass and height is provided to us, and the object is at point A, and it is raised to the point A from point B to point A, and we needed to calculate the potential energy, as we have already calculated potential energy at this point, and that was 3000 joules as we have calculated before. And we need to calculate the kinetic energy at halfway down, and the height that is provided is 5 meters, and obviously we need to calculate the kinetic energy at this point. Now you can see that the total energy is conserved in all the cases, here also, here also. Here there is no kinetic energy, and here there is no potential energy, and at the center there will be partial kinetic energy and partial potential energy. So as we have calculated, we can simply write down to like this, that at point C, that energy, total energy is and partially potential. What we need to find out? We need to find out the kinetic energy. And if it is partial, that here it means, as we know, that kinetic energy will be, if it is partially, that is potential energy by 2. And we very well know about the potential energy, that is 3000 divided by 2. So we can calculate it as 1500 joules. So kinetic energy will be equivalent to 1500 joules. Thank you. Now let us start with the third numerical. What is it? An electric heater is rated, that is 2000 watt, and how much energy does it uses in 15 hours? So what is provided to us? That power is provided to us and time is provided to us. And simply we need to calculate energy over here. Let us start. So as we very well know in the question that power P is given to us, that is 2000 watt, and we need to, time was also given, that is, time is small t, that is 15 hours. And what we need to calculate? We need to calculate the energy over here, how much it is here, and obviously we have to convert it into seconds. So this will be 15 into 60 into 60. So what the value will be? The value will be 5400 seconds. Fine with it? So this will be the time, that is 5400 seconds. And what we need to calculate? We need to calculate the energy over here. The power is what? Power is work done upon time, and that is equivalent to energy over time. Now we know the values of power and time, and simply we can calculate the value of energy over here. So energy is what will come what? That is power into time. And what is the power given here? That is 2000. And time is what? 5400. Fine with it? And the value will come here 108,000,000, and it will be 108 into 10 raised to power 6 joules. Fine with it? And so the energy will be this much. Okay. So obviously it can be also equivalent to 108 mega joules, because 10 raised to power 6 is mega. Thank you. Now let us move on to the numerical number 4, that is an object of mass m. Object is of mass m and it is moving with the constant velocity v, and we need to calculate the work done that should be done on the object to bring that object at rest. We need to bring that object at rest, and we need to calculate the work over here. And the mass m is provided to us and the constant velocity v is provided to us. So let us start with this numerical. Now mass of the object is provided to us, that is m, and velocity, that is equivalent to v, constant velocity, that is provided to us in the question. And obviously what they are saying in the question, that an object of mass m and it is moving with the constant velocity v, and it has started with the constant velocity v here, it means that initial velocity here will be v. And what we need to calculate here, we need to find out how much work should be done to bring the object at rest, and we need to calculate the work done at rest. Obviously here the initial velocity will be equivalent to v, because it has started with the constant velocity v, and the final velocity that you can consider it as 0 over here, because we need to bring that object at rest. And obviously we need to calculate the work done over here. So work done, we very well know, that is force into displacement, that is small s over here, and force is m into mass into acceleration and displacement. calculate by the Newton's third equation of motions, that is v square is equal to u square plus 2as, and s will be equivalent to v square minus u square upon 2a, and is what is v over here? V is the final velocity, that is we need to bring that object at rest. So here we will consider it as 0 square. Initial velocity we will consider it as square into 2 into a. So what will be the value of s we will get? That is minus v square upon 2a. Fine with it, and we will substitute the value of s over here, that we will get mass into acceleration, that is minus v square upon 2a, and a will be cancelled out over here. So what we will obtain, that is minus half mv square, and it will be equivalent to work done to bring that object at rest. And here work done is negative. Fine with it? Yes, we are on the fifth numerical now. The last one, find the energy in kilowatt hour. We need to find out the energy in kilowatt hour in 10 hours by 4 devices of power of 500 watt each. That we are having the 4 devices and their power is 500 each, and we need to calculate the energy in them in kilowatt hour in 10 hours. So let us start with them. So we know that power of each is 500. So now we are provided the 4 devices, each of power 500 watt, and time provided us, that is 10 hours, and we need to calculate the energy in kilowatt hour, and we need to know about the energy in kilowatt over here. So if the 4 devices each are having the power of 500 watt, then what will be the power? The total power will be equivalent to 400 multiply 500, and this will be equivalent to 2000 watt. Fine. So total power will be 2000 watt, and if you want to calculate in kilos, so this will be 2 kilowatt. Fine. This is W, capital W. And what we need to know now, we need to calculate the energy over here, as we very well know, because power is equivalent to energy upon time, that is work done upon time, or energy upon time. So what we need to calculate, time is provided to us and we need to calculate the energy. So from here we can get energy is equivalent to power into time. Fine. So what is power here? Power is total power, that is 2 kilowatt, and it is provided in hours. So yes, we need to calculate in kilowatt hours only. We can simply take time in hours. So what the answer will be? 20 kilowatt hours. So energy will be equivalent to 20 kilowatt hours over here. Thank you.